Hi, my name is Morten, and in this video we will be taking a look at dependency injection containers and inversion of control in WooCommerce. We know from experience that no commerce projects are alike, and it's only a matter of when and what you need to extend rather than if you need to extend something. As commerce projects evolve more and more and become more and more complex over the years, it's important that the platform that you use for your commerce project actually supports that growth. What it means from a technical perspective is that as a developer supporting the business, you need to be able to modify the platform to the behavior that they need. We know that from experience, and that's why all the things that we build in WooCommerce are based on the principle that we call Framework First. Framework First is basically the ability to define a set of business rules and then implement it using the set framework that we have built for the purpose. The reason behind this is that if we can implement the features that we want to support out of the box, then you can as well. So that means that you can modify the behavior based on what your needs are. And that is what makes WooCommerce a very, very strong platform in terms of flexibility, scalability, and much more. To support all this, we have defined a use case in WooCommerce that basically says that as a developer, I want to be able to extend and modify the behavior of the platform regardless of my needs. And that is what we support using the Framework First approach, a set of principles that we call SOLID, which basically teach us how to build flexible and structured code that can not only be modified, but also modified in a nice way. And that's what we're going to take a look at in this video, and how to support that using the IOC containers of the platform. So without further ado, let's jump into some code. So far, when building the website and the web shop with WooCommerce and your favorite CMS, we have been using Object Factory a lot. Object Factory is basically a wrapper around our IOC container implemented with Castlewinter. If inversion of control, IOC containers, and dependency injection is new concepts to you, then all of this might feel like a little bit of black magic, but in fact it's not. It's very simple once you get the hang of it, and you basically just need to consume the infrastructure that we have built around WooCommerce to support that. So let's try to take a look at some of the things that we're building so far. You may remember that we have resolved catalog library, transaction library, catalog context, and such things from Object Factory. So the way that it works is that we can, via configuration, tell the IOC container what components we have available. A component is basically a piece of business logic. So every time we have a piece of business logic, we usually we define an interface around it. So that could be, I want to calculate a price for a product. Then we design an interface around that allows us to implement something that can calculate a price for a product. And then we stick that implementation into the IOC container. And that's how the entire platform is composed, regardless of us talking about tax, pricing, shipping, payment, all that good stuff. Everything is business logic wrapped in some service, some interface, or some sub-framework to the platform that we then compose in the IOC container that you can use. A good example of that is the payment gateway implementations that we have. It's implemented via a framework that allows us to handle payments, and then everyone can create their own implementation for their own payment gateway. You have probably done that once or twice, maybe 3 times before in your commerce career. We define a bunch of them out of the box, between 15 or 20 payment gateway implementations, and they all adhere to the same interface that can then be resolved using the IOC container. So when you select the payment gateway on the storefront, in fact what we do is resolve the underlying service that will then communicate with the payment gateway. All of that from a code perspective is transient. We don't know what the underlying payment gateway in question are. We just know that we can initiate a payment, and then the actual implementation will do that for us. Similar goes to how we calculate a price. A price is basically something that we define in UCommerce based on a price group and a product and stuff like that. And then when we calculate a price for that, we initiate a component that can then tell us what is the price for this price group for this product. So if you want to change that behavior as well, you just define a component that does that. If you want to do something else when a product is added to cart, well, you can do that. You can define your own component and stick it into the IC container, and UCommerce will not care. We just care about the interface that we resolve, which is in this case an underlying service. So let's try to take a look on how we have done that so far. Let's go, for example, to our category navigation controller. So the category navigation controller is the first exercise we built up in this training course. And here we started to consume a bunch of interfaces in UCommerce from the ISC container. And basically what makes up a component is a service type that we are resolving. So that is the piece of business logic that we want to use. And that piece of business logic is then implemented by something. We don't know what. Usually it's just the out of the box ones. But if you define your own implementation, then you stick that into the ISC container, everything just works. In this case, we resolve iCatalog library, which is residing in a namespace called ucommerce.api. Let's just, for the good measure, also define the namespace so you can see that for yourself. So the iCatalog library is configured via XML configuration in the platform, which means that you can change it. So I'll find the configuration file for UCommerce where I know that is sitting. Let's search for iCatalog library. It's actually right here. That's the component in the ISC container that is implementing the iCatalog library interface. We can see that right here. The service, that's the one that we are requesting. So that's what we are requesting right here. I want to use from the ISC container the service that has this type. In this case, it's an interface sitting in the namespace called UCommerce API. And then the implementation can sit in any assembly whatsoever, your own, the UCommerce core one, wherever you want to use an implementation of this service for. So if we take a look at the type called catalog library, we can actually see the type right here. Catalog library is sitting in the core UCommerce APIs and assemblies. So under ucommerce.api.catalog library, we can see that it implements this interface, UCommerce API.iCatalog library. So that means that we can register this implementation of this interface in the ISC container. And then wherever iCatalog library is used, if you take a look at the implementation, you can actually see what type is being resolved from the ISC container. And that's where we have a chance to implement our own and make sure that it does what we want it to do. Similar to all the other interfaces, we can see here that catalog library are using iCatalog context, iOrder context, iIndex, iProduct price calculation service, and so on and so forth. So usually all the different dependencies that and components that UCommerce has are composed together using this pattern where dependency injection is used to use business logic. So for example, business logic to calculate a price, we inject that. We can do it in two ways, either via constructor injection, or we can also use the mandatory attribute here to inject on public properties instead. The reason that we use public properties is for upgrade purposes. So if you upgrade from, say, from one minor version to another minor version, if you have inherited one of our default components, then it will be binary compatible as we don't change the constructor arguments. For example, if we used constructor arguments and constructor injection, then we would take all of these public properties here and put them into a constructor instead, which means that if we change the constructor and you have inherited it, then when you inherit something that does not have a constructorless parameter, well, then you have to call base with those constructor arguments. And if that changes, then you will not have binary compatible in code, so you have to change your code in order to move on. It's a small thing, but something that can make quality of life a little bit better for those that use the platform on a day-to-day basis. So that's why we use public property injection instead, using this mandatory attribute that allows us to do that. When that happens, Castle Winter, which is the tool that we use for dependency injection, finds this mandatory property and say, okay, I need to set catalog context as well. So Castle Winter will find the iCatalog context implementation for that. So everywhere there's a component and an interface, you have the ability to change the behavior of that thing. And that's what we're gonna try to take a look at in this video as well, where we're gonna override one of the default components in the platform. All right, so we are back at our masterclass Visual Studio solution. And in this particular example, we're going to try to override the catalog context so we can determine what catalog we're using based on our own custom business logic. So we're gonna mimic user login. We don't have that in the training material here, but you can of course extend that in your own example if you want to. In this case, I just want to mimic it with a query string parameter and say if we have a query string parameter that says is logged in, well then that's enough for me, and then I can return a separate catalog on the website instead. To do this, we must implement the interface called iCatalog context, or let's take a look at another approach we can also use instead. So in this case, I want to create a new folder where I want to place my implementation. Here I just define my own best practices on how that would be. Usually I would just create a new Visual Studio class library and then put my business logic up there and then reference that in. But in this case, let's just use the single project that we have here. It's up to you how you want to define it. There's no rules that you need to adhere to besides your own best practices. All right, so let's create a new class and call that custom catalog context. Custom catalog context. Alright, so catalog context is a concept that we also used in the category navigation controller. Here we actually inject it in by using Object Factory to grab it. So wherever we use that, we will grab the actual type that has been configured in the IOC container. That part we'll get at in a few minutes. But here we can actually see that's what we're using. WooCommerce API iCatalog context. So what I can do here is to implement that interface. And this interface has a bunch of methods that we need to implement. Current catalog group, current catalog, current product, current category, current price group, current categories. In this case, I'm actually only interested in resolving a product catalog based on what we need. So in this particular case, we want to use a slightly different technique, which is that we can also just inherit the default implementation instead. So the default implementation in the platform will always allow you to override the different methods that are on the actual interface, which means that you don't have to override the entire thing. You can just say, okay, I just want to override current catalog. So let's just override that instead. So I don't have to care about the rest. In this case, the getter here is the one that I want to override. I also need to use the setter. In this case, I just want to say base that current catalog equals value. So the good thing about actually inheriting the default implementations in the platform is that we have our own business logic, but if we cannot adhere to that, then we can always just let UCommerce handle the default implementation instead. So the logic goes here in our getter that if we can define that the user is logged in, return our own catalog, otherwise let UCommerce handle it. That's sort of what we want to do. If we implemented the entire interface, then we always had the responsibility of figuring out on our own, and we could not rely on the default implementation. So that's a good thing about overriding the default one instead. So I only override just the thing that I need. All right, so let's try to see if we can come up with some stuff for this. So if we are logged in, we want to do that via a query-string parameter, as we don't have login capabilities in the masterclass training. The way that we do that is via a query-string parameter. HTTP context, current request, query-string is logged in, not equals to null. This gives us a boolean, so we don't care about the actual value. And just remember, this is just an example. If you want to use and create login functionality in the training course, go ahead and do that. I'm just going to bypass all that because the gist of this is to see how the IC container behaves, so the business logic becomes sort of irrelevant at this stage. So we can say if is logged in, then we want to return our own catalog. Otherwise, we'll just return base.currentCatalog. So again, we have a default strategy, and then we can always fall back to what UCommerce does out of the box. Quite nice because we then leverage a lot of the flexibility in the platform in that sense. So if we are logged in, we want to return another catalog. So we can access the catalog index, which is a public property on the default implementation. So it has already been resolved by Carsten Winter. So we can do catalog index.find, and we can specify the culture code. We don't want to do that. Where Alright, so I try to find my private catalog, so resolve a product catalog in the platform with the name private. And I do first the default because then I can again use a fallback strategy. So I want to set this to my product catalog model. So if I have a private catalog, return private catalog. Expression is always true. No. Alright, so private catalog not equals null, then we return that. Otherwise, return base.currentCatalog. And that's it. That's all we have to do in this particular case to override the behavior of what catalog we are looking at right now. However, if we build this, we can do that, and if we run it, we will actually not hit this code right now because we haven't actually done anything. We've just implemented a new class by inheriting catalog context and overriding a single method. In this case, we also have to configure that that's actually the one being picked up. So the way that we do that is via configuration. In particular, we're using XML configuration for this. There's more modern solutions where IOC containers can use code first approach, which I would normally recommend people doing. However, since UCommerce is a closed source and you need to be able to figure out what's going on, and you also want the ability to change it, then it's easier for us to ship with XML configuration. It creates more visibility, and it's easier for you to change the behavior. So we do it via XML configuration instead. The way that it happens is that we have this notion of the apps folder. So if you find the uCommerce folder under your CMS and find the apps folder, you will see that there's a bunch of folders with a bunch of configuration. We have actually already done that once in the Umbraco masterclass, where we defined the index definitions for our fields and our facets. In this case, we need to create a new one again, and we can just reuse the masterclass folder here. And let's try to just copy paste the existing one and call this catalog context. So in here we then need to specify the component that we need. So let's get rid of all this stuff. And let's try to configure the one that we actually need. The way that this works is that we have a list of components that we can register. That's what we did with the masterclass index definition. And that's actually also what we need to do in this case to get the catalog context to override. So Cast-Windsor have this notion of a component. And a component needs three properties. It needs an ID, it needs a service, and it needs a type. So that's the three key components that you need to register with a component. The ID is because you can then use that for specific constructor injection or property injection, where you know that there are multiple interface implementations of the same service, and you really do need a specific one. Then you can specify in the property injection or constructor injection that you need the component with this ID. Then that's the one that will always be used. Otherwise, Cast-Windsor will just pick the first one it can find, which is okay in most cases, but in some cases where there are multiple providers like payment gateways or pipeline tasks or something like that, then we need to be specific about it. And that's why we need to set the ID. And in this case, we actually need to reuse a ID because we only want one implementation to be there. And if you configure a component where you reuse the same ID as a previous one that was registered, then the previous one will disappear because it will be overwritten. See this as a dictionary of components where the ID is the key, and then you set the component via that ID. That's the easiest way to explain that. And that is actually what we want to do. The apps folder here is included last in the configuration chain, which means that the apps folder will always have the ability to override. It will never be the other way around, which means that if you want to override via ID, then you just need to have a configuration file sitting here in the apps folder of your website. And then uCommerce will pick it up automatically. And if you have reused the ID, then it will be overwritten. So it's very nice that this apps folder here is automatically picked up, but it also means that sometimes you want to disable something and not have it running. Instead of deleting it, you can then suffix the folder name with .disabled, which will tell Cast-Windsor to not pick it up. And you can do the same thing with the configuration files as well. If you set the configuration file to disabled, again, it will not be picked up by the IOC container. So you can turn on and off features in that way as well. So apps folder included last, override by ID, then you always ensure there's only one component in the IOC container and it's yours. Alright, so it can be hard to figure out which one you actually need. Fortunately, all the configuration files are open source. You can see them in here under your website, and then you can search for the interface that you need. In this case, I know that it's iCatalog context. It's right here. Okay, so I know it's the ID that I need to use. API catalog context. So now I'm overriding the component with that ID. I also know that the service that I'm using is iCatalog context, so I have to use that as well. So the service that we're typing in here is usually an interface. In this case, it's iCatalog context. But while we can always almost tie the service to an interface, it's not exactly the entire truth, because the service that we register here is the one that we are asking for when we need it. For example, right here, where we ask for catalog context in the object factory, we pass in iCatalog context here, and in that particular case, Castle Windsor will say, okay, let me look for a component where the service is the type you're requesting. Same goes for constructor injection and for property injection. In most cases, it's an interface, but it can also be an abstract class or a type on its own, for that matter. So that's what we register in the type here, in the service right here. The service is basically just namespace, type name, assembly name. That's how you register a type in .NET. It's not specific to Castle Windsor, that's just the type specification. So now we have registered what the service is. Now we have to set what the type is, which is the actual implementation of this service we want. So the runtime type that we are injecting, it cannot be an interface on its own, because you cannot create an instance of an interface. It has to be a particular type that are assignable from the service that we're asking for. In this case, we want to register our own catalog context. So we need to grab the namespace. And we want to grab the type name, custom catalog context. And it resides in our own assembly called Umbraco master class. Now, if you take a look at the actual type here, this is where it becomes not tricky, but it's just a little FYI, is that I'm actually not implementing the interface explicitly. I do that via the catalog context, but it's still the service that I'm requesting. I will never request catalog context. It will always be the interface. In this particular case, custom catalog context via catalog context is assignable from this interface, and that's why it works. Because in the end, it is an iCatalog context implementation. I have just inherited the default implementation and modified it slightly. So this is just a regular polymorphy in .NET. So with that said, now we have a component. Now let's try to build the solution and run it and see what happens. And then we can try out some additional cool stuff where I can see how this actually comes into play. Build succeeded. Let's hit F5 and wait for the site to start. So my site is now back up and running. Welcome to the UCommerce Masterclass. So let's try to set a breakpoint in our catalog context. Okay, so I have my breakpoint here in current catalog, and I know that current catalog is being used by my category navigation controller to render the categories. So let's try to see what happens here. It's being called, is logged in. I want to resolve current catalog. If we take a look at the actual stack trace, we can also see that that it's being used here in the category navigation controller. So we need to use current catalog, so that's what we do here. So let's try to step over this line right here. and see if we are logged in. We're not, so we just return base.currentCatalog. There we go, back up again. So right now nothing has actually happened. Let's try to pause the breakpoint just to try and change the behavior. So we're not logged in right now, and we are just returning the base catalog. So let's log into the backend and try to add in some new information. Please do remember that I'm using Umbraco in this particular case. However, I can use whatever CMS that I want to use. Sitefinity, Sitecore, Umbraco, it doesn't matter. The functionality here is the same. So I'm just going to showcase it in Umbraco, but please just do remember that this is this exact same behavior across all CMSs. So all that you see here in the masterclass is applied to all CMSs, regardless of what CMS I'm demoing this in. So back at my UCommerce installation, what I want to do here is just create a separate catalog that we can then resolve based on our business logic by setting in the crib string parameter. So I will go to my catalog app, and UCommerce is the default catalog being resolved on the storefront right now with shirt and software and support on it. So what I will do here is I will create a new one, and let's call this private. That's the catalog that I referred to in my code. So obviously we need that instead. And once we have the private catalog, we need to set a new set of categories for that, and eventually also new sets of products. But let's just create a single one here just for the demo purpose, like this. So now I have private and private. If I request my storefront again, I will still not see private, and the reason for this is of course that my business logic is not accepting the current state of the application, so to speak. So let's try to pass in is logged in equals to true. Ta-da! Now we actually see the private category instead. Let's just try to see it through in the code here as well. There we go. So we're not in this case we are actually in fact logged in. So we can now access the catalog index and say I want the private catalog, and then return that. And then now we just return the private catalog here. And that's actually it. And that is how you can leverage the IOC container to exchange business logic from the core implementation to your own custom one. That's it. I hope you enjoyed the video, and see you in the next one.